Hello everybody, welcome to my talk on Standartox, Standardizing Toxicity Data. I'm Andreas Schomüller and together with Verena Schreiner and Ralf Schäfer from the Quantitative Landscape Ecology Working Group, we worked on this project. We are from Landau and I'm already also enrolled as a PhD student at the University of Strasbourg. So, talking about chemicals in the environment, there is an increase in worldwide production and a diversification of chemicals. For example, Bernard et al. 2017 showed over the last decades an increase in global pesticide use and also an increase in approved pharmaceuticals in the US. And the chemicals, they all also arrive in the non-targeted environment, be it pesticides, personal care products, pharmaceuticals, etc. And we asking ourselves, do these chemicals cause an effect there? And to assess this risk, we can do multiple things. So we have measured a concentration in the environment. We can then compare it, for example, with regulatory thresholds. We could use an indicator that checks whether vulnerable species are there or not, or we could use toxic units or species sensitivity distributions, for example, where in the case of the toxic units, the concentration of a chemical in the environment is divided by a EC50 value from a controlled laboratory experiment. To get these values, we can either do these experiments on our own, or we use existing data. For this, we would have to search the literature or use existing toxicity databases. And luckily, there is a big database on such values, the US EPA Ecotox database, and it contains roughly 12,000 chemicals, 12,000 taxa, and 1 million test results by now, and it's quarterly released with new data added. And the really interesting thing for us is it's open for download, and we did that. We downloaded it, extracted CAS numbers and taxonomic names and queried them against other databases, for example, the Chemical Entities of Biological Interest, the PubChem database, or the WORMS database, or the Global Biodiversity Information Facility. And together with these, we created Standartox. So what did we aim for with Standartox? We wanted to create a tool that prepares and aggregates ecotoxicological test data in a reproducible and standardized way. So it is, on the one hand, a database, but also a tool. And for that, we cleaned and harmonized all the ecotox data. There were many different, up to 1,000 different units. So these are all harmonized or filtered out. We enabled filter methods to filter the test results. We have aggregation methods to aggregate the test results. And it's a tool that facilitates data retrieval through either an R package or a web tool. Showing you what parameters can be used to filter the data. We can filter the data by test parameters like the duration. We can select 48 or 96 or any other hour. We can filter them by endpoints. Do we want EC50 values or NOAC values? Or we can filter them by effect groups, be it mortality or growth. So this is also already, everything is possible at the US EPA Ecotox database by itself, but as we included new data from different resources, we can now also filter the data by chemical parameters like the chemical class, be it, for example, herbicides or fungicides, and so on. We can also filter now the organism parameters such as the habitat or where the organism occurs. And our tool allows to aggregate the data. We recommend to use therefore the geometric mean, and we already published a paper on this tool last year, And I'm now quickly walking you through the two methods to access the Standartox database, either through the R package. You can download it through GitHub or more conveniently through CRAN. And it's basically an R package that accesses an application programming interface that runs on our server, and therefore you have scriptable access to the toxicity data of Standartox. And to our knowledge, this is the only toxicity database where this is up to now possible. And this also makes it reproducible. And you can install it as all your other R packages, of course. In the R packages itself, there are two functions. There's this SDX_catalog function, which allows you to retrieve the catalog of parameters that are in Standartox. Here, for example, the habitats, and here are the names of all the parameters, so you can filter the data by the habitat, by the trophic level, by the test duration, endpoint, and so on. And all these parameters can then be passed in the actual query function, Standartox query, where you enter them simply in your script. So this would be the simple use case, but you can also query multiple inputs. You can query 3 CAS, you can query multiple CAS, 100 CAS, whatever you like. You can query multiple taxa, you can query multiple test durations, and so on. And there's also the web tool, reachable under standardocs.uni-lambda.de, and it allows you to use the same filter and aggregation methods as the R package. Though we are not sure whether we will continue the web tool, we will definitely continue the R package. Yeah, just to show you. So, lastly, I want to show you a small example on trichlorophone with the same parameters as before. We aggregate again the geometric mean, and you would get then data like this. So these are all the EPA ecotox values for trichlorophone for this specific test parameter set. Concentrations ranging over several orders of magnitude, and Standartox aggregates one single EC50 value for this specific setting for you. So, and the good thing is, or the interesting thing is, as I said before, you can do this for multiple chemicals. Here we query also for Oncorhynchus myrmecis and the same test duration, but not restricted to trichlorophone, but all the chemicals where there are tests for this fish species. And here I've plotted the 20 most tested chemicals and the exact names of the chemicals, and the exact concentration is not important here. We see the derived Standartox single aggregated values, and just to assess the quality of our estimations, we compare them with existing manually curated, manually quality checked values from another database, from the pesticide property database, and we see that overall 92% of Standartox values diverge by less than a factor of 10 from the PPDB values. So to conclude, one critique might be that we include even poorly conducted studies, because the EPA ecotox database includes all studies, it doesn't perform quality checks, but we say that it's true, but if there are enough test results, we argue that this doesn't matter much because we average them out. And on the positive side, it's a clean and easy accessible ecotoxicological database, which is constantly updated, which has version control. So in some years in the future, you can go back, use the same script, get the same version you used back then to retrieve your values. It's standardized and reproducible aggregations, and it's like the PPDB, for example, not restricted to specific chemical classes. And I want to finish my talk with an appeal. I think in ecotoxicology and ecology, we need to embrace the computer age more, and data sources must become machine readable. I think we use a lot of open source software already, but I think in terms of open data, our fields are lacking behind, and I think we not only need web tools, but we need application programming interfaces, APIs, to focus on big challenges like this 12,000 chemicals, 12,000 taxa, 1 million test results, because so many data points demand big, scalable solutions. And with that, I already want to thank you for your attention. You can find slides of my talk here at my blog. And here are the references. And a personal announcement, by the end of the year, I will probably have finished my PhD, and I will be looking for a job or a project in the field of environmental sciences, and I'm interested in environmental effects and exposure of chemicals, and I like to use tools like bioinformatics, statistics, big data analysis, and even geographic information systems. Again, thank you for your attention.